All right, welcome back. And today's demonstration, we're going to continue on with our discussion regarding the different methods of plumbing. And for today's method, what we're going to be discussing is copper pipe. And for a copper pipe, it comes in two different types of forms. You have a soft form, which is known as tubing, and a rigid form, which is what we'll be dealing with, and that's known as your piping. Just wanted to make that clear to start with before we begin and before we start dealing with our form of piping. Now, in this process of copper piping and copper plumbing, there are different forms that go about, different methods of assembly when it comes to copper. Some use a method of crimping. What we're going to be doing today is a method of soldering, also known as sweating, in a process where we use a propane torch, paste flux, and solid solder. And a few things to make very clear before we go about using this solder is the solder that we're going to be using, and this is the preferred method, especially if you're going to be using copper plumbing in your household for something like drinking water. It's very important to be very clear that when you use a solid solder, it's going to be a combination of antimony, copper, and silver. Now, back in 1986, with the passing of the Federal Safe Drinking Water Act, it's no longer allowed to be using a 50% tin and 50% lead. While they still do sell that type of solder, it's not allowed to be able to use a 50-50 tin and lead solder just due to the lead poisoning. Now, another thing to be very clear when it comes to our material that we'll be using is that when it comes to our copper piping, we have three different types of thicknesses. Now, if you refer back to our discussion regarding PVC, they use something like scheduling, 20, 40, 80. When it comes to copper, it's not by a number form. Instead, with copper piping, when it comes to, again, your scheduling being your wall thickness, when it comes to copper piping uses K, L, and M. K being the thickest wall of copper, M being the thinnest. They're rather different form when it comes to your PVC or steel using a number form as opposed to copper that uses a letter form. A few other things to mention before we actually go about with our assembly is that it's a preferred method. A few advantages to using copper. It's a preferred method as opposed to steel because it's resistant to corrosion, as well as copper being able to withstand freezing, especially being in a climate that's relative to, or quite frequently in the winter time when it gets really cold, a lot of snow, freezing temperatures. Copper can be able to withstand those freezing temperatures because of the type of material that can be able to expand in a way, whereas with steel, it tends to break. Another advantage to using your copper, in addition to that ability to be able to withstand freezing weather, is resistant to corrosion. The downside to using copper, it can leave a nasty taste. If it's a type of water that you're going to be using for drinking and it's got very, very small, even small amounts of acid, what that tends to do is leave a nasty taste, as well as leave green residue in bathtubs and sinks. You'll start to see a green residue left behind due to the acid in the water traveling through your copper pipe. Now, a few things regarding this procedure. I mentioned a few of the tools that we'll be using, from our propane torch, our solid solder, lead-free, as well as our paste flux. One tool I do want to mention to you for something like our little demonstration here, just to kind of show you exactly how this works. It's our tubing cutter. Tubing cutter looks a lot like, once we get into steel plumbing, it looks a lot like our pipe cutter, but tubing cutter, very small in form, handheld, and for something like this, very easy to use. The only thing that you got to make sure that you keep it, make sure that you do, is that you're spinning the tubing cutter around the piping in order to make its cut. Students in the past, what they wind up doing is they wrench down, they take this handle and they continue to turn without spinning the tubing cutter around. Reason why you want to make sure that you're gradually tightening as you're spinning this around is because that will pinch your pipe, and suddenly your pipe is not going to fit into your fitting. Okay? So to prevent any kind of pinch piping, spin your tubing cutter, okay, to get an even cut. And eventually what you're left behind with, just to kind of show exactly how that cut's working, eventually what you're left behind with is just a slicing of your tubing cutter. Now, another thing that winds up doing to your pipe that's real important that you adjust once you go about making your cut is that it's something that you cannot prevent from happening, okay? Because as you're tightening and as you're spinning around your tubing cutter, you're bringing the very lip of your pipe in. It's forming a burr, okay? There's an attachment on your tubing cutter. This is your reamer. There are different forms of these reamers. There are other attachments. Like I have some wire brushes where there's an additional attachment that has a little handheld reamer. And pretty much all you're doing is you're just twisting this around, and you're getting rid of that lip that kind of folds on the inside. And you're just expanding out that pipe. Not a whole lot, it's not fanning out, but you're expanding so that way you get a nice flush end to your pipe, and it's not causing any kind of obstruction. And that's where you get that downside between copper and PVC. PVC, you're not getting that lip on the end, and plus it's a really smooth synthetic in order to create plenty of wire flow and preventing any kind of clog. Whereas copper, without having that reamer, you're creating an obstruction where you can have any kind of hair. If this is going to be some sort of like a piping that's going to be used for drain, hair or any other kind of obstruction that's going to create a clog in your pipe, not running a reamer through the end of the pipe is going to continue that obstruction. Another item to make sure that or practice that you perform before actually going about assembling your copper pipe is actually cleaning the pipe as well as the joint. All right, and that's where our wire brush comes into play. And this wire brush, we're just going to be, all I'm doing is just cleaning around where the joint's going to go. I have some students that maybe they're waiting in line or talking with a buddy, and they just cleaning the entire pipe. That's not necessary. You don't need to do that, okay? Just clean the area where your fitting is going to be in place, okay? And you really tell a difference between what is the clean copper pipe as opposed to what's yet to be cleaned, all right? You can really see that nice shine. That's the area that I just cleaned off. Now, why do I do that? Well, think of it this way. Think of it for those welders out there that you're to be using a MIG welder on metal that's either painted or rusted. it leaves a lot of porosity, the weld doesn't hold, it eventually breaks off. The same thing happens with your solid solder. When you try to apply that solid solder, that copper pipe, yeah, you're going to melt off that solder, but it's not going to be a solid hold, and eventually that solder is going to break off. Okay? By cleaning up your copper pipe, what you're doing is you're creating a surface area allowing you to be able to get a solid hold between the pipe to your fitting. And this is where I'm going to be cleaning off my fitting here, okay? I'm just going to be cleaning the inside. And it doesn't hurt to get all three. You know, we're taking a T right here. If you want to kill two birds with one stone and just clean all three of these fittings, certainly do that. And again, the same thing here, where you're getting a nice shine. In my case here, with this T, I'm getting a nice shine on the inside of this, but also I'm creating an area that's going to get a solid hold for that solder to really latch onto. Now, the next item that I'm going to be making any kind of application is going to be our paste flux. Now, this flux, the purpose of this flux is to prevent any kind of oxidation. Okay, I'm going to prevent any oxidation with paste flux, as well as the flux is like a little additive to really allow that solid solder to wrap around the pipe. Okay, I want to think of it as like it's like a lubricant in a way, but really it's a nice little touch to be able to allow your solid solder to really wrap around the pipe and fitting. And I'm going to apply the flux to my little fitting, as well as around the area of pipe that will be attaching to the inside of the fitting. Now, one thing to point out is that as you are applying your torch to the area that's going to be soldered, you'll notice droplets of liquid coming from where the paste was applied, and that's just the flux that's melting off. As it is melting off, don't worry, you're not creating an area that's going to be difficult for your solder to apply. Your solder is still going to stick, it's still going to be able to wrap around, but all that's done is creating that area for that solder to latch on to between fitting in your copper pipe. Okay, so as it burns off, don't worry, you don't need to apply more. Okay. Now, another thing to point out, the additional tools that I'll have on hand whenever I'm using any copper pipe, a wet rag. Okay. It goes without saying, but a lot of people tend to forget about that, especially my students, is that when they take a torch and solder to their fitting in their pipe, what winds up happening is they sit there, they apply their solder like, oh yay, looks great. And they go about like, all right, I'm going to start on my next piping, and they go ahead and they just start grabbing it. Okay? To avoid any burns, have a wet rag on hand to cool off your metal. Okay? So, to avoid any kind of burns. All right. So I'll go ahead and I'll start my torch. Before moving on to my next item of discussion, and that's going to be my area of where I'm going to apply my torch and solder. Okay? And for those of you new to this whole method, a few things to point out. I'm lighting this propane torch with just a striker. Okay, so as I'm applying my torch, I'll have my torch right here on the bottom. It doesn't matter, you have it on the side or over on the top, whatever floats your boat. But for me, I like to apply my torch right alongside the bottom of my fitting. I'm going to turn it down just a hair. Now, you don't need to have a whole lot of, you don't need to go too crazy with your propane torch and have a huge flame off of that. Because by having too much heat, you're just going to have chunks of that solder just break apart and fall. It makes the job a lot harder and takes a lot longer. Okay? By having a nice small cone coming off of your propane torch, that's plenty. That's plenty to be able to heat up both the fitting as well as the pipe. Now, one thing I want to point out, I will not be applying my flame to the exact same side that I have my solder. Here's why. Again, it goes back to that same problem I just mentioned, where I have chunks of that solder just breaking off, falling, and not sticking to my pipe and joint. The other issue is this: nothing's going to stick, or whatever does stick just stays in that same area. I'm not going to get a complete wrap of that solder. By having the torch underneath the opposite side from where I have my solder, what I allow myself to do is have complete coverage of the entire pipe and fitting. Also, one other thing, I'll go even a step further. By applying my torch, notice the placement of my torch is just a little bit further down from where the lip of that fitting is. By being a little bit further down, what I'm having my solder do is travel down that fitting. Okay, it'll wrap around and really concentrate around where that heavy source of heat is. So it'll travel down that fitting and get more coverage of the pipe that's within your fitting. So I'm just going to sit here, just let it heat up a little bit. Kind of let that flux cook a little bit. You'll notice it starts to fizzle, boil, and droplets of that melted flux. Again, don't worry, you do not need to apply more flux, just leave it as is. And what I'm going to do is I'm just going to give a little scratch. I'm scratching my solder. And there we have it. Okay, practice what I preach. I got a wet rag here. Okay, so just to kind of show exactly what does it look like, all right, so here's where I was applying my solder at the very top, and right at the very bottom, I have it tends to wrap around, it settles right at the bottom, coming out the other end, but also if you notice on the inside of our tubing here, you'll see the solder is traveling down the other end of the fitting, okay? A little tough to see because it's a little dark inside, but you'll see as if you have the torch down your fitting, as opposed to just heating up either dead center or right at that lip. If you have your torch down your fitting, your solder will travel down that fitting as well, getting full coverage, not just settling right at the lip of the T, okay? You want to have full coverage within that fitting where the pipe is going to be nestled in. So that way you get full coverage of solder and get a great hold, great adhesive of solder to pipe and fitting. Okay? But that concludes our demonstration of copper piping. Very simple, very fun, especially those that enjoy playing with torch to those welders out there that like to have torch to metal.